All right, cool. That's recording, right? Yeah. All right, cool. So, hello everyone. Welcome to MacX Build 2D Games with Java. So, before I start today's event, I'd like to acknowledge the traditional owners of the land on which we are gathered today. My name's Robbie. I'm from the events team at the Monash Association of Coding, MAC for short. And before I begin, I'll introduce our club and who we are. So MAC is a tech club that focuses on imparting valuable tech skills and industry relevant experience to students. And our goal is to foster the tech culture at Monash and provide a collaborative setting for students to learn from one another, build upon the skills they'll need for a career in tech, and make some friends along the way. And don't forget to check us out on social media. Someone should share that in the chat in just a moment. And again, just to remind everyone, I'll go to this slide now. So please have the notes open for this. You will need it. It's there so that if you do miss anything, you should be able to just catch up. And also, there'll be all the required imports listed on there because that's going to be most likely an error that a lot of you will easily pop into. So yeah, definitely have that open. And then I'll give a few minutes as well, just for everyone to start up a blank Java project. And while everyone's doing that, just so I can sort of gauge how much Java people have done before in here, would you just be able to give any Zoom reaction if you've like touched Java at least somewhat before, or even if you're just here to follow, like you're just going to watch and follow along, just so I know who I need to explain, if I need to explain some Java things. Really, like any Java is enough. We're not doing anything sort of crazy with it. Yeah, if you've done 2099, this should be a breeze basically. And yeah, any other coding experience, you'll have basic enough knowledge for this for sure. All right, I'll briefly mention some of the Java things when I go through it, but for the most part, I think we'll be okay. So that's great. And then also, if you can download the assets folder, so it's highlighted in yellow on the notes at the very top. So download that folder and then just put it in your project directory. So in the same folder that will have your source folder in it. So that will have all the images. It's got the font as well, although we're probably not going to get to that today, but it'll have everything you need in it to make the basic game. So I'll just wait a few more minutes just to make sure everyone is getting that. How to open Java. Do you have Java downloaded already? If not, maybe Sai, did you want to paste that link that you sent before and again? You've got Java. Cool. Do you have an editor or an IDE, maybe VS Code? Repository? We're not using a repository. We're doing this from scratch. I do have a full version, which I will share at the end, but for now, we're going to actually build this from scratch. So get another reaction, like a thumb, you open Java and nothing happens. Yeah, Java itself, you need to open something you can edit Java in. So if you have like an IDE, maybe VS Code or something. So I'm going to be using IntelliJ. I'd really recommend that. If you have it, it'll make things a lot easier. A text editor is something that you use to edit code. You will need to install one. In the notes at the top, there should be a link to IntelliJ. You may be able to download that quickly. But for everyone else so far, if I could get another thumbs up if you've managed to get a blank Java project that looks something like this. So you've got your source folder and then the assets folder in the same directory. Just a few more people joining in just then. So if we could just get the notes link sent again, that would be good. So yeah, for those who have just joined, open up the notes as well as starting a new Java project and then downloading the assets folder. I am just sort of waiting a little bit now to make sure that everyone's got this part set up and good to go, because as long as we get this part working, we'll be fine. Okay, so I'm going to get started with a little bit of the content to cover. So we won't be coding right away. So the first thing I'm really briefly just going to discuss is the libraries that we're going to use. So we're only using basically two, and we don't need to download anything for this. They're all just standard Java imports. So we're going to use AWT, which is Abstract Window Toolkit. It's the really old school API for anything GUI in Java. And then a tiny bit of Swing, which is the new version essentially of AWT. It's built on top of it. But for the most part, we only need AWT. So that's all we're really going to need to use. And we just have Swing for the JFrame. So for now, I'm going to go to my project and I'm just going to create our first class. You may already have a class created called app or something if you use VS Code. I'm just going to create one called game. And then from here, I'm just going to declare a bunch of constants. So if you haven't done Java, these will look a little bit funny, but we declare them like this: public, static, final. Public means we can access from outside the class. Static means we don't need an instance of the class instantiated to access this. And final means it's not going to change. So we're going to declare three integers: the game's width, the height, and then another height for the ground, which is like the ground level where the dinosaur and obstacles will be standing on. And this is just going to make it really easy for us later on to get all these values when we need them. So three of those like that. And as well, to save the typing, feel free to copy and paste from the notes if you'd like. I'm just going to type everything out if you'd like to follow. So the dimensions are going to be 800 by 400, and the ground will be at a height of 250. And I will note now that the window that is used in these Java applications, the coordinates start at the very top left and then move down and to the right. So 250 is 250 pixels downwards. So we will have to take that into account later on, but for now it doesn't mean too much. And then I'm going to create one more variable, a Boolean called running, which is just going to initially be false. Sorry, I'm getting like Zoom notifications and it keeps tabbing me out of my IntelliJ. So if you guys could get on, just admit those, that would be great. Thanks. And then, yeah, I'm going to create a constructor at the moment that's just going to be empty, as well as my main method, which in IntelliJ you can do very quickly by typing PSVM, and then a start method as well. And that's the method we're going to call when we want to start the game. And then from here, I'm just going to add a configuration. So IntelliJ knows what class to run when we actually want to run the game. If you're doing this in VS Code or something else, it may not have something like this. So you just need to make sure that you're in the game class with your main method when you hit play. So when you run this, nothing's going to happen, but that's good. So the process exited, so things are running fine. So up to this point, is everyone okay? You're able to run this and get an exit code 0 with no errors, anything like that? No one said that they've had errors or anything, so hopefully that means everyone's okay. Okay, so from here, I'm going to now make this class an extension of Canvas, which I will import. So you're wondering what that is, so I will discuss that now. So in Java graphics, there's really just three main things we need to know about three classes. So the first is a graphics object. All this is it's just a big class that has a whole bunch of information and methods all encapsulated together so that you can render stuff onto the screen. And then the canvas object, you can basically just think of it as a really big rectangle, which you can render like images, shapes, squares, anything onto. And the JFrame, it's just any sort of application window. So something with a close button on it, a minimize button. And what you do is you can put a canvas object basically just inside a JFrame. And from there, you can render things onto it. And that's what your application is made up of. So what we'll do next is actually create a class that will hold the game's window. So I'm going to call it game window. Feel free to call it whatever you like. And then from here, all this class has is a constructor, which is going to take in 4 arguments. So a width, a height, a title, and then it's going to need an instance of the game that we just created earlier. Because what we're going to actually do is run the game from within inside this window as soon as we open it. So the first method we call is this set preferred size. It takes a dimension argument. So you just create a new dimension and you can pass in the width and height that we've taken in the constructor. And this just tells the window what size it should be. And then from here, I'm going to create that JFrame object that I mentioned earlier. So you just create a new one and then you can give it the title. So the title is just what will appear at the top of the window. And then there's basically just a bunch of operations you have to do every time you create one of these objects so that they behave normally. So feel free to copy paste all of them because there's quite a few, but I'll quickly run through each and explain what they do. So the first one is set default close operation. What this one does, and the argument you pass it is exit on close. This just tells you that when you press close, that the application should stop because you obviously don't want it to keep running when you've closed the window. And then for now, we are going to make it so you can't resize the window. So you can do that with this method. Frame.pack is a bit mysterious, but it basically just sets every object to its preferred size. If you don't call it, you will just have a minuscule window that doesn't do anything. And this set location relative to null just means that whenever you open the window, it'll appear in the middle of the screen. And then lastly, you want to make the frame visible. So we just call set visible true. And then one more thing is that from here, I'm going to call the game's start method. So essentially what will happen, we create a new instance of this class. And we'll go through all these operations and then it'll call the game start method. So here, all we have to do to basically start our game is create a new instance of the game window in our main method. And so what do we want to pass it? We just want to initially pass it these values we've given it here. So the game's width, the game's height, the title we'll call just dino game, and then we'll create a new instance of this class itself. And from there, if we press play, it's going to build and we get a window, which at the moment does not have any size for some reason. See if you can spot the bug before I do. Oh, I forgot it. We didn't add the game. So we also need to add the game that we passed it as well. So the game is the canvas object. So I guess this illustrates what the canvas is. So when I press play now, we can see that we actually have this. So that's what the canvas was. And before, because I hadn't added it, that's why we didn't have anything below here. So I will stop for just a moment and hopefully everyone is able to get a window popping up. Let me know if you've had any trouble or anything. no one's saying they've had trouble, so I will, you got a problem? We've got time, so happy to wait a moment and see if we can fix things. Frame.add game has an error. Did you extend the game as a canvas class? Yeah, it should work now. So try that. Hopefully it does. Cool. Chris, what was your problem? Can't seem to add the title dino game. What do you mean? Do you have it in the constructor here maybe? Maybe you'd left it out of here. Okay, well, for the moment, I'm going to move on, but just double check the notes. Everything in the notes should match up to what I'm doing. So if you do get like a small bug or something like that, just have a scan through the notes and hopefully everything in there will match up with what you've got. So we've got this method now that once we run the window, we're calling this start method. So this is where we want to start our game from. So we'll now talk about what a game loop is. So a game loop, it really just controls the entire management of the game. And there's two main or three sort of things that it does. The two main ones are rendering and then updating the state of the game. You also in this loop are sort of implicitly handling keyboard input, but in Java, it's done super easily through a separate thread. So we actually don't have to worry about that. The main things we're doing and we'll have to manually put in our loop are the tick and the render. So what the tick will do, it's just the method that's going to update every state of every object in the game to what it should be at its next point in time. So the example here is we're, say, changing x coordinates by their velocity. And then the rendering is just in charge of putting the image onto the screen. And you can just do this in a cycle. So the simplest way you could make a game loop is just say while running, tick, and then render. But there's one huge problem with doing it this way, is that this while running loop is just going to run as fast as your computer can run. So it means it's going to update the game as fast as your computer can do it and then render as fast. And that's going to be a problem because if you know what frames per second are, right? So that's how many times you're rendering to the screen. So someone whose computer can say do 120 frames per second, their game won't be running 60, like twice as fast as someone who's got 60 frames per second. It's just rendering faster. So we somehow need to de-link these two objects, these two methods together so that we allow the rendering to happen really fast, but the tick to happen at a constant rate. So this is when we get to a method called delta time. So I'm not going to go into the nitty gritty of sort of how it works, but basically what you're doing is calculating how much time there should be between each frame and then keeping the tick rate at a constant amount. So in this case, we've got a frame rate lower than the ticks. So you may ask, well, what happens when the frames are higher than the ticks, which will be the case in this game because it's really easy to render. So this is actually something that you guys were mentioning Minecraft before. Minecraft famously has only a tick rate of 20. So it actually only updates 20 times per second. But of course, we can run Minecraft way faster than 20 frames per second. So what's actually happening here is we're either extrapolating or interpolating frames between each tick so that you do get a smooth image. So you're essentially estimating where the frame should be, not actually updating it. any faster than 20 frames per second. I just thought I'd mention this. We're not going to be handling this in our game because it's super difficult. But for now, we'll go and make the delta time loop. So before we do that, we'll create our tick and render methods. They're both just public void. And then from there, I'm going to be super lazy and like everyone else, just copy the entire loop from the notes because it'll take way too long to type out. And there's a bunch of funny stuff going on. So if you go to the loop, the notes, you should see the public void start method in the section a better game loop. And then just paste that in here. And if you've got these two tick and render methods like this shouldn't cause any errors whatsoever. And then from here, if you press play, what we'll now see is, give it a minute. Yeah, there you go. We're printing out the frames per second and the ticks now to the console as well. So at the moment, because we're doing nothing, we've got a whopping frame rate of 29 million frames per second, but you can see we've now kept the tick rate constant. So while people are getting that up and running, I thought for fun, maybe if you could put whatever frame rate you're getting into the chat and we can just sort of see who gets the fastest. It's just basically a competition of who's got the beefiest computer. Oh, 29 million again. That's basically what I had as well. 18 million from Alden. 36 million, 27 million. They're all kind of relatively close. Nice. Oh, it's good to see so many people have got it working. Okay, cool. Anyone having troubles up to this point? All right, cool. I think everyone's doing pretty okay, and there's quite a few of you there who've managed to follow on so far, so that's awesome. So the next concept I'm going to talk about is of a buffer strategy. So when you're rendering something to the screen, you're not actually drawing the image live when you call that extra or that render method each time. What you're actually doing is, yes, Ruben, there is a notes. If someone can just paste that into the chat, you should be able to use that to catch up. Yeah, cool. Thanks, Sid. So yeah, as I was saying, you're not actually rendering that image live. You're loading a preloaded image, which is normally stored in what you call a buffer. And there's different algorithms and strategies of the way it's done. So here I've illustrated what's called the page flipping algorithm. So you have two back buffers. One is used for like loading or drawing an image. So you have this one buffer that's stored loading an image, which is 2 frames away. You have a preloaded image, which is 1 frame away from the current frame. And then you have the current frame. And what you do is once this one gets loaded in the next, you just flip it basically. And this just repeats. So you use these 2 frames in memory to alternatively load one and then display the other one onto the screen so that you don't fall behind your rendering process. And luckily for us, because that seems a little bit difficult to do, we actually don't have to write any of that manually because Java has a buffer strategy class that will automatically do this for us and work out the most optimal algorithm, even depending on your system as well. So the way we'll do this is we'll first create one of these buffer strategy objects in our render method. Just call it something like BS. And what we do is, because of this is the canvas object, we can retrieve that from it. And then from here, there's essentially just a line or 2 of code that says if we don't have a buffer strategy yet, we need to now create one. This. And then the number of buffers that you pass it, the page flipping one I showed you before has 3. So 2 or 3 work fine. Anything more than that is way too excessive for a small game. So 2 or 3, I'm just going to do 3. There's a bit of debate online about whether, like, what actually is the optimal amount. But again, this is a really simple game, so there's not going to be really any difference whatsoever. And so now we're going to use this buffer strategy object to now get that graphics object that I mentioned earlier. So you do buffer strategy.get draw graphics. And then what you would do from here is, this is where you'd draw anything. So this graphics object basically has a whole bunch of methods in it. So like if I type g dot, you can see all these methods in here, which you can use to draw stuff. So we'll be using draw image later on. And yeah, this is the sort of part in here where you would put all of those methods. And then once you've done that, because it's sort of done in a layering method, you have to get rid of the old graphics that you were using before. But again, because we've preloaded this into the buffer, this isn't getting rid of the frame. And then from there, you just type show, and then that will present the loaded frame onto the screen. And so to test this out a bit, we'll add some sort of simple stuff to create our background. So you'll see that this has a very sort of strict layering approach to how you do things. So first, say we set the color to white, and then we could draw a rectangle. So the rectangle is going to start at 0, 0, which is the top left. We want to go then to the very bottom right. So we then just pass in the game width and height. And then now say from here, we want to draw a black line just to represent the ground for now. You now have to go down to the next line and now set the color to black. And then after that is when you draw the line. So it is a bit fiddly how you sort of do this very strict way of sort of one line after the other, setting the color, then drawing the line. But for our purposes, it's completely fine. So the line, it's going to start at 0, and then the height of the ground. And then it's going to go across by the game width and finish at the height of the ground as well. Cool. No, game width. This should be ground height. Yeah, ground height, ground height. Cool. So if we try that out now, null pointer exception. Let's see what I've messed up this time. I forgot to return out of here. Yeah, easy mistake. Cool. Try that again. Nice. We have a line on the screen. Very exciting, I know, but we'll get there, don't worry. And you can see now the frames actually drops by quite a lot because we actually are rendering something now. All right, cool. Are people able to get a line on the screen? Cool, one reaction. Yep. Yep. Nice. The line is a slope. Maybe try double check the coordinates you did it from. I initially messed it up, but yeah, we're starting it at 0 and then the height of the ground, and then finishing at the width of the game and then the height of the ground. You may have put like game height or something like that in one of those ones. Cool. Awesome. All right. I'll move on to the next thing now, which is now we're sort of at the point where we want to actually add the cool stuff into the game. So the dinosaur and then the cacti. So these objects are going to share a lot of functionality between them. So we'll use a little bit of FIT 2099 knowledge, and we'll make an abstract class, which we're going to extend for each of these. And what these classes are going to have in them, they'll have a tick and a render method as well. So like with the main program where we're calling tick and render, we're going to have a tick and a render for each of these objects too. So individually, they'll have a render method, which draws it onto the screen, and a tick method, which will say update their position. And then we'll also have a method for loading a sprite and getting a hitbox as well. So we can start coding this out now. We'll create a new class, call it game object, and declare it abstract. And then from here, I'll just mention two. For those who do know Java, the access modifiers we're going to use are pretty sort of useless. So if you do like actually use packages, they'll mean something, but we're all doing this in just one folder, so they won't mean much. But for now, we are just going to make these values protected. So we'll start off giving float values for the position, so X and Y. And then we'll also make two more for the velocity in each of those directions too. So dx and dy. And then from there, we will make another variable, which will be a buffered image. It's just an image basically that we can store. And we'll call that the sprite. And then we'll just make a constructor for the X and the Y like that. Yep, that's all good. And then we'll start writing out some of the methods. So the tick method is really simple. Basically, at each tick, all we want to do is change the X and Y coordinates by the speed in that direction. So we just have to do X plus equals dx and Y plus equals dy. And then the render method, it's going to actually take two arguments. So we need a graphics object first to be able to get the method to draw graphics and image onto the screen. It's the import statements. Yes, so if you go to the notes, you'll notice at the top, there should be a page highlighted in orange, and it lists all the import statements for each class. Because yeah, just in case you're not using IntelliJ, it may not automatically do them. Yeah, so just feel free to copy paste all of those imports into each class. And then, yeah, the second object is an image observer. Don't need to really worry about too much what it is, just you need it to be able to draw an image onto the screen. And then from here, we're gonna call our graphics object and use the draw image method. And the image we're gonna be drawing is that sprite we've stored earlier. And then from there, we have to cast our floats to X and Y. This is probably not the best thing to do. You may get a bit of flickering and stuff because we need to store these as floats so we can sort of, because we don't want to be only restricted to moving them by integer values, but it does mean that we then have to cast them to integers every time we want to display something on the screen. And then one other thing to do is, as I mentioned earlier, the window itself, if I just comment this out for a second. So the coordinates start at 0, 0 here. So 250 is 250 from the top down here. So when we go to draw the image, if we just say leave it at like say 100 and then 250, it'll display it down here basically because the coordinates start at the top left. So what we have to do is subtract the height from its y coordinate. And then that'll give it so that it is sitting at the top of the ground. So we can do sprite.getHeight. And then you just have to pass in that observer object at the end. And that's the render method. And then from there, we also need a method, which I'm going to leave static for now in case you want to use it from other classes, that can just load like a path name from our assets folder right into the buffered image. So it'll take a string, image path, and we need to do this in a try catch in case we have problems loading our file. So you do image.io.read. This takes a file, so you create a new file, and then you just give it the, I didn't import, cool. And then you just give it the string that you want. So we give it the image path like that. And then you need to catch the IO exception. And yeah, feel free to copy any of these methods from the notes too, if you don't want to type them out. And then I'll just like print something out like error opening file if we have problems, and return null otherwise. Cool. So this should give us the basic framework for putting something onto the screen, some sort of object that we can move around. So let's test it out by trying to create the player now, or the dinosaur, whatever you would like to call it. So we start off by just saying extends game object. We need to make a constructor for it. Now we know what the player's initial coordinates are, so we don't need that in there. We'll say it'll be about like 50 pixels across from the left, so it's not the very far left. And then we can just reference that static ground height again from the game class. And then to load the sprite, you just call that load sprite method and then pass in the file name from the assets folder. So it's dino.png. And now if we press play, nothing's going to happen yet because we haven't added it into the game. So what we'll do is create a player variable called player. I'm going to instantiate it in the constructor. Like that. And then basically for all the objects, this is where you start using your tick and render methods. So at each tick, we also want to call our player and tick over that. And then in the render method, just below here, when we've drawn our stuff, we also want to call player.render as well. And then the graphics object is the same one we're using from before. And then that image observer object is just the canvas itself. So now if we press play, we have a dinosaur. Yay. How are people going up to this point? Anything you need me to quickly go over again? Okay, I think we're good so far. We're good on time as well. So, all right, let's talk about the next thing, which is keyboard input. And luckily for us, Java makes this super, super easy to do. So there's an interface called key listener, which when you implement it, it tells that class that it's a key listener. So it will then react to key presses on the keyboard. So I've tried to sort of illustrate what happens here, but when you press something on the keyboard, it'll alert your key listener, which then passes a key event into 3 different methods that it has to have. So there's key pressed, key typed, and key released. We only need key pressed. So if you press spacebar, alert your key listener, and then basically just think of it as passing the spacebar as an argument into the key press method. And then from there, you just do whatever you want. And, you know, when you press that key, it'll do whatever happens here. So we'll go back to our game class and we will now implement that interface. So you can see we need to implement those methods. So they're the 3 there. So I'm just going to minimize the ones we don't need. We just need key pressed. And before we do that too, the game is a key listener, but it also needs to sort of know that it's going to be the one handling its own key sort of actions, if that makes sense. So you have to do add key listener this. So you could actually create, and it's probably a better idea if you're going to do more things with this, to have a separate class that's a key listener and say like key handler. And then here, when you add the key listener, you're passing in a key handler object. And then you would handle all of those key events outside in a different class. But here we're only doing one thing, which is pressing the spacebar. So we're just going to do it within this class itself. Cool. So to work out what key was pressed, so remember, this is just going to get, the key event will get passed in automatically. So first, to work out what key was pressed, you can store it as an integer by calling this get key code on the key event. And these are just all stored in a big enum. So you can say if key is key event, and then if you press dot, you'll see all of them here. So they start with VK. So VK underscore space is the spacebar. And so now, just to test it out, if we put something like 1 into the console, when I press spacebar, we can see a 1 showing up down here. That's working good. So now, obviously, we want to make the player jump when we press the spacebar. So let's start thinking about how we'll do that. So to start off with, let's create a Boolean within the player that is just going to say whether or not they're jumping or not. So initially false. And then we'll create a method that will call whenever we want the player to jump. So say jump action. Okay. So first of all, before we do anything, make sure that when we press the jump or when we press spacebar, that the player is not already jumping, because we don't want them to be able to jump multiple times in the air. So we'll stay if not jumping. And then we'll make jumping true. And then just to test things out, we won't do anything fancy, but let's just see what happens when we set the y velocity to something. So again, remembering that because the coordinates go positively downwards, to make the player move up, we need to set this to a negative value. So if we set this to say -8, we go back here and we'll now replace that call with the jump action from the player. We will see that pressing space makes the dinosaur fly into the air. That's good, that's a start. We now have to work out how to make the player fall back down. Now, at the moment, in our game object, all we're doing in our tick is changing these coordinates by the velocity in each direction, but we're going to need to do a bit more. So we actually are going to override that tick method. And again, for the people not too familiar with Java, this just says we're going to do something different to what this is saying we do. And whenever we call the tick method on the player, it'll do what we tell it to do now. So we still need to move the y coordinate by what we told it to. We didn't really need the x change because the player's only ever going to move up and down. So we can just leave the y one. And so from here, let's first just sort of try and imitate gravity, because it's actually pretty simple. So you say if jumping, you just want to increase the velocity upwards by some value downwards so that they slowly the velocity slows down, eventually becomes in the opposite direction and then falls back down. So in this case, it's adding a positive value. So it's initially quite negative, so it moves very fast, slows down, and then initially comes back down. So you just sort of basically add a constant amount to your velocity. So say like 0.3, and F tells it that that's a float, so it doesn't get confused. So if we try that now, the dinosaur falls back down, but they fall off the screen. So we need to account for that too. So we'll do this as well. You basically just want to say if jumping and the next sort of position, so that the current position plus our current velocity y is, if that's going to be greater than the ground height, we want them to stop jumping, because again, it's greater than because the coordinates go downwards. And so what do we do here? We'll first set jumping to false, and we want to change the position of the y coordinate now to the ground height. And then finally set the velocity to 0 too. And I'll wrap that in an else if. So now if we try, there we go. Looks like jumping is working good. So how's everybody going with this so far? You try running, it says an error opening image file. Yes, assets should be in the same directory as source. Make sure you have it and you're calling assets / as well. The sprite. Yeah, a few people missed key listener, so I'm happy to go over that again. Was it just the how we actually do this part, or like the concept behind it? The tick method in game. I'll go over the key listener first. So you start off by making your game an implementation of key listener. So you just do implements key listener at the top. And then from there, there'll be 3 methods that you have to implement, which are these 3 here. And then just quickly going over what this did again. So this gets passed in a key event automatically whenever you press a key. You can get the code of that key, so you know which key was pressed by calling get key code. And then from there, if key is the spacebar, you call the jump action. I'll go over the tick method in game. So the tick method in game at the moment is just calling player.tick. That's the only thing we have in the game tick over at the moment, is just the player. And the game constructor, yes, I can show you that. The game constructor is just initializing a player and then adding in the key listener, which is itself. Did I go over any of those things too fast and you need me to see them again? I'm happy to, because we've got time. Right, hopefully everyone's good. We will have a bit of time potentially at the end as well if you need to catch up on anything, and I'm happy to stick around for a bit too. All right, so we have the player, we just don't have obstacles yet. So we'll start by now creating our obstacle class. So similarly to the player, we are going to extend game object like that, create a constructor for it. So the obstacle is going to start at the very far right off the screen. So its X will pass as the game width, and the Y, like before, should be the ground height too. Now, because we want to have a bit of variety in our game and have different types of obstacles, what we're going to do is make a sort of method to randomly generate obstacles, randomly generate the image for the obstacles. So we'll create an array list first, which is going to store all the strings in here of the obstacle images. So we'll call it, say, sprite paths, like that. And then from here in the constructor, I'm just going to add each of those sprites, so the names for them, into this array list. So the first one, assets / cactus1.png. And just do that a few times over and change each. And I guess I'll mention too, for those who maybe are familiar with a little bit of game stuff, we are obviously not using sprite sheets. We're just using single images to make things simple because they've already been sized correctly. Where is the tick and jump action method to go? Yeah. So the tick, there's 2 ticks. So there's one tick in game, and then there's the tick in player as well. So the tick in player just tells the player what it should do each turn. And then the tick in game is just ticking over all of these objects, basically just calling this method. So this jump action and tick here are in player. And then the tick in game is just calling the player's tick. Hopefully you're able to get that sorted. All right, so from there, we're now just going to load in a sprite randomly for one of these. So I'm kind of all going to do it in one method, but I'll try to explain it. So we want to get an index of one of the ones in the array first. So we'll do sprite paths.get, and we want to get the index randomly. So we'll create a new random object. We'll get an integer, and the bound is going to be the size of the sprite paths array. Hopefully that made sense. Otherwise, just feel free to copy paste that in. Okay, that's actually all we have to do for the obstacle, but it's going to it doesn't really appear clear how we now get multiple obstacles across the screen and sort of manage their speed and generate them randomly too and things like that. So to do all of that, we are going to create a new class for it. So we'll create a new class and we'll call it obstacle handler. And I guess before I go on to that, is everyone good with the obstacle? Anyone need me to go over anything else before I continue? If everything's okay. Okay, so from here, we'll start off by creating an array list that's going to store all the obstacles that are currently on the screen. Can't spell, cool. So this array list will just have every obstacle in it that is going to be currently on the screen. And as well as this, I'm going to create 2 floats to store what will be the sort of speed of every obstacle as well, because we need to keep this consistent too. So one will be the velocity, and then we also need acceleration too, because we want the obstacles to speed up over time. So we'll give that a pretty small value as well. What did I say? Yeah, 0.001. And the F just means as a float. And then because we're going to need to generate a lot of random numbers, we'll create a random object too. Cool. Okay, and then now we're going to need a tick and a render method for this class as well. So you're starting to see probably a pattern. With that game loop, we tick and then we render, and that's kind of how every object needs to operate. So we'll make a tick. This class doesn't need a constructor. Okay, and then this render needs the 2 arguments that we normally use as well. So a graphics object and then an image observer. Okay, so we'll start off with the tick method. So we want to generate obstacles randomly. So what we're going to use is this random object to generate a value between 0 and 1 and essentially use that as a sort of probability that we can compare against and generate obstacles based off of. So let's generate one. So we'll make it a double. We'll just call it a variable called rand. And what we'll do is we'll say if this value is say less than something like 0.01, that's a 1% chance, but it's a 1% chance each tick. So it'll happen quite a lot. So this has to be pretty low. You can feel free to edit these values to change the difficulty of the game later on. So if our value is lower than this 1% chance, we are just going to add an obstacle to our array like that. And then if you see the notes, there's a few other things we're going to do as well. So this is a bit of a messy method, but that's fine. What we're going to do is increase our velocity by the acceleration value. And then now we actually need to tick over every obstacle too. So we can loop over them by doing a loop like this. And then from here, we want to make sure that this value is the same for all of our obstacles. So we can just set that. And then we'll call tick. And then the last thing to do in the tick method is, so we don't waste a whole bunch of memory with way too many obstacles, we want to make sure that we are removing them when they're off the screen. So we can just do that by saying, if this obstacle's, say, X value is less than something like negative, say 100 should be more than enough, we just have to remove it. And then break out so we don't crash anything. Okay, and then after that, we need the render method. So again, we're going to loop over each obstacle. And then we just call the render method as we did for the player. And we've got these two arguments. So we pass in the graphics object and then the observer. Oh, that's got a line there. That's all good. It should be everything for the obstacle handler. Does this sort of make sense? So what I'll do then from there is, like with the player, we need to add this into the game as well. So we'll create a field for it, something like that. And then need to instantiate it as well. And now add it to the tick and render methods like before too. So that's just copying exactly what we did for the player, now for the obstacle handler too. So if you press play now, we've got obstacles on the screen. That's good. Now there's a few things you'll notice. The first one being that obviously we're not colliding with it. We'll handle that later. But also the obstacles are sometimes in sort of really unfair or weird positions. So we want to be able to space them apart somehow to make the game a little bit more fair, I guess. So we'll go back to the obstacle handler, and we're now going to store a new variable in here, which is going to keep track of the time that we last generated an obstacle. So we'll create it as a long type and call it something like last obstacle. And then what we do here, if we generate an obstacle, we want to set this value to the current time. So you can get the current time by doing system.current_time in milliseconds. And then in this check here, when we're also checking against our randomly generated value, we want to make sure that there was a decent amount of time between now, so the current time, and the last time we generated an obstacle. So we subtract that value and see if it's something greater than, like, say, 600 milliseconds. Again, you can play around with this and see what works best. So now if we press play, we generate obstacles, but they're also at a sort of decent amount of time apart. Has anyone fallen behind at anywhere up to this point and wants me to go over anything again? Because we have a good amount of time, so I'm happy to help out. Is the render method in game on the notes in game? Let me check. We have the render method in making the dino game part. We just haven't explicitly shown the adding of every single thing after the player, but all of this part should be in it. It is in just in making the dino game, that section under the player class at the bottom. Yeah. And then, yep, you would just have to up the obstacle handler in as well once you've created that. Cool. So really there's only one sort of last thing to do before we have the basic game down, which is collisions. So we're going to handle this really simply using rectangle objects in Java. So a rectangle is literally what the name says, it's just a rectangle. And they already have some inbuilt methods where you can check if they're intersecting. So we'll start off by creating a method in game object to get a hitbox for an object. And that hitbox will just be that rectangle that I mentioned. So it's going to return a rectangle, this method, public rectangle. We'll call it get hitbox. And then how we do this, we create a new rectangle. We'll call it hitbox, is a new rectangle. Now we're going to generate the hitboxes in the simplest way possible, which is to just give them the dimensions of the player's sprite, basically. It's not a great way to do it because obviously the corners will be sort of extending way too far out. So feel free to maybe play around afterwards to try and make a better hitbox. Maybe you want to make it a bit smaller than the picture size, or add like a polygon maybe. But for now, we're just going to use a simple rectangle. And the dimensions will be the sprite's width and the sprite's height, like that. So this is a rectangle that's the size and width of the sprite. We now have to put it in the same position as the object that we're getting it for. So we can do hitbox.setLocation, and we just have to pass in the X and Y casted as well, like before, to integers, and displaying them in the same way. So we need to subtract the sprite's height too. And then finally, we just return it. So we have this method to be able to get a hitbox. There's one more thing we have to add as well. We're going to be comparing against all the obstacles too. I declared this private. I could probably leave it protected and just be lazy, but I'll make a getter for it for now. So IntelliJ is nice. You can do Command N and then just do this like that. But I don't want to return the actual reference. I'm going to return just a shallow copy of it. So that'll just retrieve our obstacles array from the obstacle handler class so we can use it outside. And then in the game, we just have to make one new method to detect the collisions. So we'll call it detect collisions. And because we don't really have many objects on the screen at any one point in time, we can literally just brute force this and check every obstacle against the player and see whether they're colliding. So we are just going to loop over every obstacle in the obstacle handler's array list. So we get that by calling the obstacle handler we have, and then the getter we just made. And then from there, we just have this kind of long line of code, which just says, if the player's hitbox intersects, so this is the intersects method for a rectangle. Now the argument you pass it to check whether it's intersecting is just another rectangle. So we'll just use the obstacles hitbox like that. So this checks if they're intersecting, and if they are, we want to stop the game. So we just say running equals false, and we'll return. And finally, we have to make sure we're calling that. So we're going to call that each tick. So in the tick method here, we just call detect collisions. And now we should, if we hit an obstacle, stop the game. And there you can see the problem with the hitboxes we made, because they are just the size of the image. They kind of stop a little bit further off, but we do have the game running. Cool. So up to this point, have people been able to get where I am? Because this is, for the most part, what I wanted to get through. And there's a couple other things I can do since we have a little bit of extra time. But if anyone needs catching up to this point, I'm happy to help out as well. All right. Missing stuff from game. What sort of stuff? Are you getting errors somewhere? What errors are you getting that might point me in the right direction? Save score. I can get to that. Yeah. So we'll get through the last little like things that I can maybe add. The one thing I think I'll add in the free time we have is, because as we notice it, the game, the whole application just stops at the moment when we hit an obstacle. So we want to make it so that when we press play again, we can start a new game. So I think I'll do that quickly. And then after that, I can go through like the score and things like that. Added object handler into render method. Yes. So it's just literally below where the player render is, just between the dispose and the other draw stuff. Cool. Error for obstacles variable in detect collisions. If you were just trying to retrieve the obstacle maybe from here, it's probably because you need a getter first because it was left as private. If you want to be lazy, just feel free to change the obstacles method to like protected or public and then just call it from obstacles. But other words, I just made a getter. Yeah. Cool. Okay, so in the tiny little bit of time left, I'll see if I can get through the game state, which is the first little extension I recommended at the bottom. So this is just going to mean that we can restart the game if we want to when the game ends. So we'll create an enum first that's just going to store a bunch of values that can let us check the state of the game. So we'll make one not playing, one playing, and then one game over. How are you running with so many red squigglies? Oh, these aren't red squigglies, these are orange squigglies, which is just IntelliJ telling me to do things that are more Java friendly. So they're not actually errors. It's just sort of like, you should be doing this because it thinks that I should be, like this suggesting that it should be final. Final means it's not changing. So if this variable never changes during our program, IntelliJ tells me, well, it should be final, but I'm not bothering about doing that because we will be changing this in just a moment. So yeah, so for the rest of the state, we basically then just go through, and I'll probably go through this a bit quicker now. I'm kind of doing it from memory too, so hopefully I remember everything. We are adding a bunch of checks against these values to determine what we should do. So we'll first create our own state method attribute, which is initially going to be not playing. And then when we run the game, we want to set the state to playing. And then in the tick, we only want to tick when we're playing. And you just wrap that in there. And then when the game ends, we want to set the state to not playing. And we won't set running to false anymore because we're going to let the game keep running. And then now we just change, we're going to add a bunch of extra conditions in our key pressed. So depending on whenever we press space, we want to do something different. So for the moment, before I do that, I'll just check that the game still stops when we hit an obstacle. So yeah, that's good. So now, because we only tick when our value is playing, we're still able to let the game run, even though we've hit an obstacle and it appears we've stopped. So we don't have to halt the entire application now, which is good. So now, say we're in that state. So we'll first check, we press spacebar. If the state is playing, we want to have spacebar make us jump. Otherwise, if the state is game over, we want to restart the game. And the way to do that is to just create a new player and then create a new obstacle handler and then set running to true. I think that's everything. I'll just try it. So I hit an obstacle, I press space. No, not quite everything. What have I forgotten? Running equals true. Did I set the state? No, I need to set the state to playing as well. Running is always true. I don't know why I added that. I've got something too. I'm doing this from memory just because these are the things I was going to do in the spare time. Let's see if anyone can maybe fix this for me as well. Plays new player, new obstacle handler, state the plane. Did I ever set to game over? Ah, yes, you're right. I set it to not playing instead of game over. Yeah, good pickup. Yeah. Thanks, guys. Nice. Cool. There we go. Got it. Awesome. Good debugging skills. And then, yeah, if you want to go one step further, I don't think I'll bother, but you can also wait until that you press the first spacebar, then you start the playing game, the game playing. And yeah, so what I will do for now is wrap up the official part of the session. So first thing before anyone leaves is to please fill out the feedback form. So we're using Typeform now, so hopefully it'll be a bit more fun and less boring than Google Forms. So either scan this QR code here, or click the link Viv just sent in the chat. And yeah, it literally only takes 1 minute, maybe even 30 seconds, and will help so much. So yeah, be as critical as you like. Your feedback does make our events better. So yeah, we'd really appreciate that. And then if you would like to see the entire game with the scoreboard added and the like clouds and reset button and things like that, you can go to this GitHub page here. And what I can also do is, since we have finished a bit early as well, I'm happy to go over the actual full project as well if anyone has a request to see a certain part of it. So yeah, I think someone mentioned they'd like to see the score. So I will open up the actual project and I'll run it too so you guys can see it as well. And yeah, thanks for coming, everyone. So feel free to stick around if you want to see the full game that I have here. Otherwise, you are free to go. And you have to fill out the feedback form before you go. Okay. So yeah, here is the full version. So this has the score added, as well as some clouds moving in the background. And then this reset button here as well. So the score, it's probably the most involved part of the rest of it. So basically, you create a new object to hold the score, but you're obviously now dealing with fonts instead of sprites. So that's the main image compared to your, the main difference compared to your other game objects. So you first need a method to load in fonts. And I think I did that in a, yeah, I've done quite a few things differently in here. So I also have this sprite handler class to put everything in one sort of place. So to load fonts, it's similar-ish to the images. There's basically, you can create fonts and store them as a font object, and you pass in a file as well, but there's a couple of other sort of funny little methods you have to call and arguments you have to pass it. But this loads in a font, and we basically load in the font that we've got in that assets folder there. And from there, we obviously have to do a few other things. So one of them is padding all the strings as well. So this method just pads each string to a length of 5 with zeros. Clearing the score is pretty simple. And then for the render part, we do have a few more things than just calling the draw image. So we have to set the font, we set its color, and then the draw string is how we actually put a string onto the screen. So we have the high score on the left, and then we then set the color to black and then do the actual score. And then these positions I've kind of just manually worked out where they go. There'd be a much better way to do this to actually like work out how long the string is. I've just manually put in the positions. So yeah, you set the color to gray, draw the high score, then set the color to black and draw the actual score. And then in your tick is where you're updating the score. So we have the high score and current score as fields, and you're just updating the current score at each tick. I have a timer as well, so we update every 1 millisecond. And then when we clear, if the current score is bigger than the high score, we just set the high score to the current score. And then this is called every time we have a game over, basically. So in the game class, I have, I think, a method in here somewhere that actually does all of it at once. Yeah, here. I have a reset method that creates all new objects and then clears it. Thanks for coming, guys. Yeah, feel free to go. I'm not keeping you here hostage. It's just for those interested. Someone mentioned they were interested in the score, so I thought I'd go over it. Yeah, any other requests as people leave? If anyone who wants to stay around and see any other parts of the game. Thank you. Thanks for coming, guys. Thanks, Alden. I'll stop the recording too.